Hi, welcome to the video. My name is Pushpinder Gill, and today we are going to do the remainder problems which come in GMAT, GRE, and CAT, right? So mostly in GMAT and CAT. CAT will have more tough problems. In GMAT will have a little bit more sophisticated problems. And when it comes to GRE, I think the first section of this video will cover all the questions in the GRE, right? So this would be the web address, that is perfect-scores.com, where you can explore more about us. And don't forget to like us on the Facebook page, which is facebook.com/perfectscores. And don't forget to send us your valuable feedback as well, which is perfectscores89@gmail.com. So let's go ahead and get started, guys. So before we start with any questions, let's understand the basics of remainder. So let's suppose if I divide 49 by, let's say, 5. If I divide 49 by 5, I'll have 9 into 45, 9 into 5 equal to 45, and I'll be left with remainder 4. Now I can say that this 49 is actually equal to 9 into 5, 9 into 5 plus 4 plus 4. So let's suppose if I talk in terms of variables, I divide x by y and I do something and I get r remainder and the quotient is q, then I can say that this number is equal to y into q plus r, right? So this is the way you denote a division, right? So let's suppose if I say 23 divided by x gives me remainder 4, right? So how would you denote this in terms of an equation? You can say that this number 23 is actually equal to x into some number, let's suppose y, plus the remainder, which is equal to 4, right? So this is the basic that you use, and in this basic, in this division over here, r is nothing but the remainder. It's called as something which remains, which is the remainder. uh, this q over here is the quotient, right? It's just a term that it's used all the time. uh, x over here is the dividend, right? Something which gets divided, and y over here is the divisor, right? So these are the four terms which are used. X over here is the dividend, y over here is the divisor, q over here is the quotient, and r over here is the remainder, right? So what do you get? The problems that you get are remainder problems, and in every question, so if you've seen the previous CAT versions, you would find a remainder question in almost every previous CAT, right? In almost every previous CAT, you'll find one remainder question, and in GMAT as well, you find so many remainder problems in GMAT prep that which we'll do in the remainder data sufficiency as well, right? So let's see, one thing is called as the remainder theorem. Now this is very, very important when it comes to understanding the remainder problems. So let's suppose 15 divided by let's say 3 gives, now let's not say 3, let's pick up another number. Let's say 17 divided by 3, the remainder that we get from here, when you divide 17 by 3, the remainder is equal to plus 2. And let's say 5 divided by 3, the remainder, it's again plus 2, right? So 17 divided by 3, the remainder is plus 2, and 5 divided by 3, this remainder is plus 2. If I say what will be the remainder of 17 plus 5 divided by 3, that would be equal to 17 plus 5 is going to be equal to 22, 22 by 3, so the remainder would be plus 1. Now if I say from 17 the remainder would be plus 2, from 5 the remainder would be plus 2, if I add both the remainders, it is going to be plus 4, and when this is again divided by 3 from here, I get remainder plus 1. Let's take another example. Let's say that uh, 11 divided by 7, the remainder is plus 4, and 10 divided by 7, the remainder is plus 3, right? 11 divided by 7 remainder is plus 4, and 10 divided by 7 remainder is plus 3. Now if I divide 11 plus 10 by 7, the remainders will also get added because the numbers are getting added. So I will have plus 4 plus 3, that is plus 7 as remainder, which is equivalent to 0 remainder, which is what my expression is telling me. You want to take another example? Let's say another example is 13 divided by 7. The remainder is plus 6, right? And let's not take plus 6. Let's say 11 divided by 7. The remainder is plus 4. And 9 divided by 7. The remainder is plus 2, right? So what will be the remainder when 11 plus 9 is divided by 7? The remainders will also get added. The remainders would be 4 plus 2, 6. And if you calculate this 20 by 7, the remainder is actually equal to 6. That means what do I need to state here? What I'm trying to tell you guys, I'm trying to tell you is that, just a second. So what I'm trying to tell you is that whatever operation you do on all the numbers, the same operation will get done to the average. So let's suppose, even if I talk about subtraction, 11 divided by 7, the remainder is plus 4, and 9 divided by 7, the remainder is plus 2. What will be the remainder when 11 minus 7, 9 is divided by 7? That is going to be 2 by 7, hence the remainder is plus 2. That is also equal to 4 minus 2, which is equal to 2. Let's take for another example, 11 divided by 7, the remainder is plus 4. 9 divided by 7, the remainder is plus 2. What will be the remainder when 11 into 9 is divided by 7? That would be 99 by 7, which would be equal to plus 1, because 98 is completely divisible by 7. And even if I multiply both the remainders, I will get plus 4 into plus 2, which is equal to plus 8. And when I divide plus 8 by 7, the remainder is plus 1, right? So I suppose you're understanding what I'm trying to do here is, I'm trying to tell you that whatever operation you do on the numbers, the same operation gets done to the remainders. And for CAT, GMAT and GRE purposes, for test purposes, remember that it will be valid for plus, it will be valid for negative, and it will be valid for multiplication. You should remember that these three things it will be valid to. So let's suppose x divided by y, the remainder is r1, and z divided by y, the remainder is r2. Then x plus z divided by y, the remainder would be r1 plus r2, and x minus z divided by y, the remainder would be r1 minus r2, and x into z divided by y, the remainder would be r1 into r2, right? So this is what what I'm trying to tell you here is that whatever operation you do on all the numbers, same operation will get done to the average, right? So whatever operation you do on all the numbers, the same operation will get done to the average. This is what the remainder theorem tells about. Now, before we even start doing any questions, understand that remainder always has patterns. It always come in patterns, and this is something that you should be looking forward to when a sneaky or when a difficult question comes in your play. Let's suppose I ask you, what is the remainder when 2 to the power 84 is divided by 7? That means when this kind of question is asked, don't expect the question to, don't expect to solve 2 to the power 84. There will always be a pattern which is emerging. See this. 2 divided by 7, what is the remainder? Plus 2. Uh, 4 divided by 7, what is the remainder? Plus 4. 8 divided by 7, what is the remainder? Plus 1. 16 divided by 7, what is the remainder? Plus 2. 32 divided by 7, what is the remainder? Plus 4. Can you see a pattern emerging? Yes. So whenever these kind of questions are there which involves exponents, always take patterns into consideration, right? So patterns will always be there whenever the question has exponents, and the question asks you to compute big things, to compute huge things, right? So keep that in mind, right? So let's go ahead and solve some questions. So what I'm going to do here is I'm going to solve only good questions. I'm not going to solve any simple questions because I know that you will be able to solve the simple questions with what I have shown you here. So I need to take the opportunity. I'm taking the opportunity to solve some good questions. So this is actually a previous CAT question. It's a CAT 2000 questions for our viewers outside the country, for our viewers outside India, GCAT is actually one notch tougher than the GMAT. So the questions actually are a little bit more trickier than the questions in the GMAT. So the question says that n is equal to 1421 into 1423 into 1425. The question is asking what is the remainder when n is divided by 12. Now again, what you have to do is, again, it's saying that whatever remainder that I get from here, here and here, it will get multiplied and I will get that remainder. What is the remainder when 1421 is divided by 12, right? So what is the remainder when 1421 is divided by 12? So if I try and calculate it, this is going to be 2, this is going to be 2, this is going to be 10 here, and 1 comes down, 12 8 are 96. So I will have plus 5 remainder when 1421 is divided by 12. When 1423 is divided by 12, I will have plus 7 remainder, and over here I will have plus 9 remainder. Since these numbers are getting multiplied to each other, what will I do is I will actually multiply these remainders, and what will I get? I will get 35 into 9, and I will get, if I calculate 35 into 9, 9 into 3 is 27, 315. I will get 315. So instead of me multiplying these numbers and then dividing it by 12, what I can do is I can find the product of their remainders and then divide that by 12, and I will be able to know what is the remainder when this product is divided by 12. So 12 times 2 is 24, and what I'm going to have here is 7 and 5, and 12 times 6 is 72. That means I'm going to have plus 3 remainder when this whole expression is divided by 12. Right? Easy, isn't it? So if the toughest exam in the nation offers such easy questions, then it's all about you being logical. It's nothing about you being too mathematical or anything like that. All you have to do is just understand that whatever operation you do on all the numbers, the same operation will get to the remainders as well. So from here I got plus 5 remainder, from here I got plus 7 remainder, from here I got plus 9 remainder, and I just multiplied all the remainders, and this is what I got. And whatever operation I did on the numbers, the same operation get done on the remainders. Let's move on to the next question, guys. Okay, now let's do this question. So the question says that z is a positive integer and a multiple of 2, and p is equal to 4 to the power z. What is the remainder when z is divided by 10? Remember what I told you about these kind of questions? These kind of questions will always have a pattern, right? All you have to do is focus all your energy to observe a pattern. Now z over here is a positive integer and a multiple of 2. So z can be 2, 4, 6, 8 and so on. Now p is equal to 4 to the power z. So p is equal to 4 to the power 2, 4 to the power 4, 4 to the power 6, 4 to the power 8 and so on. Now the question is asking what is the remainder when p is divided by 10? What is the remainder when this is divided by 10? Now whenever the question asks you something something something, is what is the remainder when this is divided by 10? Now what is so special about division by 10 and the remainders? Now when you divide something by 10, the remainder is always equal to the units digit of the number. Let's divide 23 by 10. The remainder is 3. Let's divide 497 by 10. The remainder is 7. Let's divide 490 by 10. The remainder is 0, right? So whenever you divide something by 10, keep that in mind. All you have to do is just find the units digit of the number. So what is the units digit of 4 to the power 2? It's 16, so the units digit is 6. What is the units digit of 4 to the power 6? Is 256, so the units digit is 6. What is the units digit of 2 to the power 12? It's again 6. That means there is going to be a pattern, and all you have to do is just try to find that pattern, right? So over here the units digit will always be 6, hence the remainder when this is divided by 10 will always be equal to 6, right? So suppose you're understanding And suppose I'm giving you enough triggers so that you can actually solve these questions all by yourself, right? Okay. Now let's see this question. So the question says that the integers 3401 and 32506. So it's again a previous CAT question, guys. Uh, when divided by a number, leave the same remainder, right? They leave a same remainder. Then what is the value of n? Now this number over here and this number over here, when they are divided by n, they leave the same remainder. That means let's suppose that remainder is actually equal to r, right? So there will be a number here, r back here, which would actually be divisible by the 3-digit number n, and there would be a number here, r back here, which would actually be divisible by n, right? Because when you divide this number, there is a number here falls r short of 32506, and when you divide this number again by when you divide this by a 3-digit number, it again there's a number here divisible by n, which again falls r short of that number. Let's suppose this number here is a and this number here is b. Now a minus b would actually be divisible by the 3-digit number n, right? A minus b would actually be divisible by that 3-digit number n. Now why am I saying that? Because I know that a is divisible by n and b is divisible by n, so the difference will be divisible by n. Just the same case, 21 is divisible by 3, 15 is divisible by 3, and the difference is divisible by 3. So if their difference is divisible by n, so their difference will also be divisible by n. Why is that? Because I'm going r forward here and I'm going r forward here. That means the difference 32506 and 34041 would actually be divisible by n. So what is the difference? If I try to calculate the difference between both the numbers, that comes down to 5 and that comes down to 6 and that comes down to 4 and just a second. Alright, I'm calculating it wrong. It's 34041 minus 32506, right? So 11 minus 6 is 5 and this is 3, this is 9 and this is 1. So difference between both of these numbers is 1935, and 1935 is divisible by which of the number? So if I try to check, it is just divisible by 307. If I multiply 307 by, let's say, 307 into, if I multiply it by 15, 15, 7 into 5 would be 35, and there'll be 3 here, and 5 3 are 15. So into 7 times 1 would be 7, right? And just a second. So 1935 divided by, so I can just calculate it that way as well. So 307 multiplied by, let's say, 5, right? So 7 5 are 35 and 5 3 are 15. Is it coming down to be 5? Oh, okay. It's coming down to be equal to 5 only, right? 1535, right? So that means 307 is my answer. Hence, question solved easily. So what I did over here was, as you've clearly seen, that I just drew a diagram and I found out the numbers which are divisible by n. If these numbers are divisible by n, their difference will also be divisible by n. And what I'm doing here, I'm going r forward here, I'm going r forward here. That means difference between these two numbers will also be divisible by n. So if you see these questions, these previous CAT questions, they will never ask you to solve something very easy. Why is that? Because come on, it's actually the toughest, the toughest exam in the nation when it comes to MBA exams. So they will never ask you something which is too easy. So always try to come up with something like this in all the questions. Never expect the question to give you the answer the usual way. Those theorems, those basics are just the basic layout for you to solve the question. Otherwise, you'll have to come up with this for each and every question, right? So suppose you're understanding this, guys. Moving forward, now the question says that on dividing a number by 3, 4, and 7, so if I divide a number by 3, the remainder is 2. If I divide a number by 4, the remainder is 1. And if I divide a number by 7, the remainder is 4 again. Now the question says that if the same number is divided by 84, then what is the remainder, right? So these are my answer options: 80, 76, 53. I'm not going to play too much emphasis on none of these right now. I'm just going to go by these three answer options. So the question is saying, uh, what is the remainder when that number is divisible by 84, right? So this is what I have to find out. Now these are the remainders when the number is divided by 84. That means if I add 84 to all the numbers, I would actually get, a little bit idea about those numbers. So 80 plus 84 is 164. 76 plus 84 is going to be 6 and 4 is 0, and this is going to be 160, and 53 and 84 would be 137. Now the question says that when you divide that number by 4, the remainder should be 1. So when you divide this number by 4, the remainder is 0. So this is eliminated. When you divide this number by 4, the remainder is 0 again. Hence this is eliminated. Now let's try out this number here. Now when I divide this number by 3, what is the remainder, right? So when I divide this number by 3, what is the remainder? As you can clearly see that 4 times 3 is 12, 1 and 7 divided by 5 is 15, right? So 2 is the remainder, which is actually meeting my criteria. When I divide this number by 4, I will get 136 here, and the remainder would be plus 1. And when I divide this number by 7, what will I get? 7 times 1 is 7. I will have 67, and 7 9s are 63, and the remainder would be plus 4. That means it's actually meeting all my conditions. Hence this over here is my answer, right? So I actually back solved in this question and got to my answer very easily. So clearly you can see there that the question says that what is the remainder when the same number is divided by 84. If these are the remainders, I can actually add 84 to all the numbers. I'll get an idea about these numbers, and from there I will go ahead and double check. See, if this wouldn't have worked, if 84 wouldn't have worked, I would have added 84 into 2 to all the numbers, and I will get my answer, 99.99% of times. Very odd scenario, I won't be able to get my answer. Then I need to be very adaptive and very flexible and change my approach there and then. So suppose you're understanding this question the way I'm doing here is, again, it's a previous CAT question, right? So moving on, guys. Again, the question is asking what is the remainder when 2 to the power 256 is divided by 17. So whenever you get something like this, always expect there to be a pattern. Never give up on pattern, guys. Always try to find the pattern. So what is the remainder when 2 to the power 1 is divided by 17 is 2. When 2 to the power 2, that is 4, is divided by 17, the remainder is 4. When 2 to the power 3, 8 is divided by 17, the remainder is 8. When 2 to the power 4 is divided by 17, when 32 is divided by 17, the remainder is plus 15. 2 to the power 664 is divided by 17, the remainder is plus, that is going to be 68 minus 4. 17 into 3 is 51, and 51 and 64 is plus 13. When 2 to the power 7, that is 128, it's divided by 17. So what is the remainder? So I can say 17 times 7 is 49, and 717 is 119. 119 from 128, the remainder is going to be plus 9. 2 to the power 8 divided by 17, right, which is going to be 256. 2 to the power 8 divided by 17, what will be the remainder? So what I have to do is 170 plus 34. or let's say plus 68, that is going to be 8 and 13 and 238, plus I'll add 17 more, 15, 3, 4, 5, 255. So the remainder is plus 1, right? 2 to the power 9, that is going to be 512. What will be the remainder when I divide 512 by 17? So 17 into 30 is 510. So it's the remainder when 2 to the power 9 is divided by 17, it's plus 2. You can see the pattern has started to emerge. You want to double check your pattern? Well, we'll do that. We should be expecting a 4 here. Now, what is 2 to the power 10? It's 1024, right? So let's find out the remainder when 1024 is divided by 17. So 1024 is divided by 17. So I'm going to have 17, 5 is 85, right? 17 into 6 is 102, right? I have less left and I'll have plus 4 remainder. So you can see this pattern has started to emerge now, right? 2, 4, 8, 16, 15, 13, this, and 2, 4, blah, blah, blah. This pattern would actually start to emerge. Now, what is the remainder when 2 to the power 256 is divided by 17? Now, 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16. All the numbers which are divisible by 8 would come here. 8 comes here, 16 will come here, and 32 will come here, 24 will come here. Hence 256, which is also divisible by 8, will come here, and the remainder when 2 to the power 256 is divided by 17 is equal to plus 1. Hence answer option 4 is my answer, right? So what I did here is I actually believe that there will be a pattern emerging, and I found out the pattern no matter what. And even if it took me 9 terms, you should believe that whenever there are exponents involved uh, in the questions, like in these kind of questions, always expect patterns to be there, right? So suppose what I'm trying to do here is, suppose you're understanding. Thank you very much. Let's move forward, guys. Now let's check out this question. This is again a previous CAT question. So the question says that when 16 to the power 3 plus 17 to the power 3 plus 18 to the power 3 plus 19 to the power 3 is divided by 70, what is the remainder? So you can clearly see there is a 0 involved here. That means the units digit would actually decide what will be the remainder of these numbers, isn't it? As you can clearly see, if I say when 144 is divided by 70, the remainder is plus 4. Whenever the units digit is 0, what you can do is you can actually decide the units digit would be the deciding factor of the remainder all the time. Okay, so what is the units digit when 16 to the power 3? So 6 is going to have its own cycle. If you remember the cyclicity video, 6 into 1 is 6, 6 into 2 is 6, sorry, 6 to the power 1 is 6, 6 to the power 2 it's again 6 at the back, 6 to the power 3 again 6 at the back. So what, no matter what happens, 6 will always remain at the back no matter what the power to the 6 is. That means over here the units digit is going to be equal to 6. Let's talk about 7. 7 to the power 1 is 7. 7 square is 49, and 7 cube is, you just multiply the last digit by 7, it's gonna be 3, right? So it's 343, but even we're just concerned about the last digit. So over here the last digit would be equal to 3. Let's talk about 8. 8 to the power 1 is 8. 8 to the power 2 is 64. 8 to the power 3 is again into 8. That means 8 4s are 32. There's going to be a 2 at the end. So 8 will give me a 2 at the end. Let's talk about 9. 9 to the power 1 is 9. 9 to the power 2 is 81. And 9 to the power 3 is 9 again at the end. That means this will give me 9 at the end. So what will be the units digit of this whole sum? That would be 6 plus 3, which is 9, plus 9 plus 2, which is 11. That means the units digit of this whole addition would be equal to 0, right? So the units digit of this whole expression will be equal to 0. Okay. Now let's suppose if you see these answer options, 0 is one possible answer. Okay. Now when I divide this number by 70 and the remainder is 1, right? If the remainder is 1, then again there has to be 1 at the back of the number, which is not possible because 0 is the units digit. Same goes for 69, same goes for 35, hence 0 is my remainder, hence A is my answer option. I could have understood if you said that 20 or 0, between 20 and 0 I wouldn't have made out what is the remainder. Well, 20 is something that I would have made out, but since in the answer options there is only one answer option which has 0 at the end, that means answer option A is my answer, right? So suppose you're understanding what I'm trying to do here. There were two triggers in this question. One trigger was the exponents, that means there has to be something about the pattern, right? And the other thing was, so one thing was definitely the patterns. The other thing was 0 at the end, right? So whenever 0 is at the end, units digit is the one which decides everything, right? So just take care of that. So suppose you've understood this one, guys. Moving forward, again this question has a little bit of factorials involved. That means there is again going to be a pattern in this question. So the question says that p is equal to 1 factorial. There's going to be a plus here. I'm sorry, there was a plus in the question. So p is equal to 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial and so on. So the question says that what is the remainder when p plus 2 is divided by 11 factorial. Now let's try to find a pattern here. Let's suppose p is equal to just 1 factorial. Then p plus 2 would actually be equal to 1 factorial, which is 1, plus 2, which is 3. And since the series went till 10 factorial here, and he asked me to divide by 11 factorial, the series is going to 1 factorial. Let me do one thing. Let me divide p plus 2 by, it's 11 factorial here, by 2 factorial, right? Let me try and do that. Let me try to divide 3 plus 3 by 2 factorial. So the remainder over here would be plus 1. Let me go to the next series. Let's say p is equal to 1 factorial plus 2 into 2 factorial. Let's suppose this is the case. Then p would be equal to 1 plus 2 into 2, 4, that is 5. Hence p plus 2 would actually be equal to 7. And if I divide 7 by, if this is 2 factorial, 3 factorial, the remainder would still be 1. Let me give you another series. Let's say p is equal to this whole number plus 3 into 3 factorial. So the value of p is going to be equal to 5 plus 6 into 3, 18. 18 plus 5 is equal to 23. P plus 2 would actually be equal to 25. And if I divide 25 by 4 factorial, the remainder will still be 1. So either I can actually go forward, keep going forward and keep getting remainder equal to 1, or I can understand the remainder will always remain to be 1 no matter what happens. Hence my answer is option 4. Again guys, try to find patterns in the question. Always try to find patterns in the question. That is very, very crucial to the question, right? So suppose you're understanding here, try to find patterns whenever you see something like this, whenever you see something like, sorry, whenever you see something like let's say this, whenever you see something like this, right? So whenever you see something like this, try to find patterns, guys. It's very, very important that you find patterns. So this was about the video, guys. Thank you very much for watching this video and being part of Perfect Scores. So this was the first video on remainders, or the first video on number system. Will come on the second video on remainders as well, where I talk about how to tackle remainder problems in data sufficiency, right? So this would be the web address to explore more about us. Don't forget to give us a like on Facebook, and keep giving us your feedback. I'm loving your feedback, guys. Thank you very much. Keep watching. See you in the next video.